designing to make funnel flow work when handling a difficult flowing material. In summary, funnel flow is our first in, last out flow pattern. With funnel flow, the material shears through itself from the top down. And the key indication that you have funnel flow is that you have stagnant material along the bin walls. Now, funnel flow is often treated like the ugly stepchild of flow patterns, but it is more than appropriate when handling the right materials in the right application. And frankly, there are many situations in which we need to make funnel flow work, including when handling a difficult flowing material. A good example are large storage applications where you don't have the luxury of having steep sloping walls. For example, if you are reclaiming from below a pile, or even from below a flat floor, or from the hull of a self-unloading ship. These are all examples of where we need to make funnel flow work. The good news is that we can make funnel flow work even when handling difficult flowing materials, as long as we abide by one basic rule, that the effective discharge opening of our outlet is greater than the bulk solid's piping dimension. The piping dimension is a minimum diameter for a circular opening and a minimum width and length for a rectangular opening. If the effective outlet is not greater than the piping dimension, then the storage and feed arrangement will be susceptible to chronic rat holing. The piping dimension is derived from a bench scale test, the shear test. Now, here comes the tough news. The piping dimension for most difficult flowing materials can be very, very big. It is not uncommon that if you are designing a small storage bin, that you would find that the piping dimension or minimum discharge outlet is actually bigger than the bin itself. In these cases, you are forced to design for mass flow, where the minimum discharge outlet required for reliable flow is much, much smaller. But when you are designing larger storage applications, where you have an opportunity to integrate a bigger discharge opening, you have the opportunity to handle the material in funnel flow. Another critical point. The physical discharge opening of the storage and feed system is only a part of the story. Remember, good bin design is a game with gravity, where we need to ensure that gravity is sufficient to break the strength of the material at the outlet and keep the storage and feed system discharging reliably. And so we need to look at the discharge outlet through the eyes of gravity. And what we see is that gravity is indifferent about the physical opening. What gravity cares about is the effective opening. That is the opening through which material is actually discharging from. Remember, the bigger the effective opening, the more stress gravity is applying on the material at the outlet. The more stress on the material, the harder it is to form a stable arch or rat hole and bridge. In summary, we can handle difficult flowing materials in funnel flow as long as we design a large and long effective discharge opening. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the KamengoU website and download our white paper.